Now let's go to the trading data, Plotviz. We already saw that, and remember this is from olden times, 1986, and let's get rid of these axes. Let's do let's switch on the labels. Let's do a select. Now we have the names of all the, the labels of all, because I selected all points by making a very big selection. Then we got all these country names put in there, and we have the look at the label. We have the number of the point and the cluster which is in, and we have the blue ones which are the other cluster without any special name, and we have the Commonwealth, the Communist, and the South American clusters. So that's that. We could take the unnamed, set the rest, and we could change them from spheres to some other shape. We can make them all triangles, you see, so that makes them stand out even better if we make them triangles. That's your choice. And again, I'm just using the left mouse, the ordinary mouse button, and I'm just using my trackball to move things around. So that's that. Trading data. Now we come to the solvent data. Let's make it big. Oh, by mistake, I made it too small. Let's make it bigger. Okay, so this has glyphs already defined on it. And some of them, the labels are actually named labels, like hydrophilic or double bond, which I'm not quite certain. If we go to this level 11, we have quite a few of those. They're spheres. And that's of the greenish color. We can change that color if we like it to a light blue. So, and then we can go back to a greenish, different color here. We can even make them or we'll make them this funny color here. So that's what all those are. That was the numerous. So use the hydrophilic to see which they are. You just unselect them. So those are those three nice spheres here. The double bond of those two there, which are actually very near the hydrophilic. That's what sort of this plot tells you. Says these points are pretty near each other, although that. And then the perfluoro are way over here. They're all together, but they're way away from these other ones. All right, so that's this particular mapping was done by the deterministic annealing version of generated topographic mapping. Deterministic annealing gets you more reliable answers. And now we finally want to do the last two examples, which are the, come back to the slides. We'll do this will be a bigger case for 146K points. So probably our poor old computer will get unhappy. Let's get rid of that while it's doing its thing here. I'm almost certain I did that right, so let's get it really started properly. I didn't click hard enough. Sometimes that happens in Windows. You don't click hard enough, and sometimes you're not certain whether it was slow because it was starting up or slow because you didn't actually properly do it. So you can see Plotviz is diligently reading the data. It's not ready to do anything very intelligent yet. That's typical Windows program. We'll have to wait. Here we are. It's coming up. So here we have 446 sequences. They're mapped into 3 dimensions. They're colored in a way that we don't want to discuss here. And here we are. So as these are actually have no glyphs, even though there are 446 of them, you can actually manipulate them quite well. You can see it's quite responsive. It's glyphs that make it unresponsive. And so you can really see the structure here. There's a lot of very interesting structure here, which correspond presumably to some families. So this is fungi data. And so these presumably are fungi families. So we can just rotate it to make it clearer. And the coloring here is the coloring of clusters that we found by a separate clustering program. And you can see this tells you immediately the quality of the clusters, namely, if we look over here, let's actually look at that. So we can go over here, press C. Then we moved it, so we're at that clustering point. Let's get rid of these measurable axes. And so we've now seen the small cluster here. We can make it bigger. So this is actually sort of a cluster, but it's not terribly impressive. You can see these clusters everywhere. So if I go to over here, these clusters are pretty clear clusters. But this purple and this yellow one, but they have these tails. The tails tend to correspond to mismeasurements, the length dependence of the distance of determination. And then you can sort of study here. You can look at this white thing over here, which is, because there are about 100 clusters here, the coloring is not unique. So you don't actually know directly what the white ones are. We can probably use this labeling. So actually we didn't set the labeling on. Let's set the labeling on. Now label is finally true. And here we get a typical point here. We can see what all these things are. They're in cluster 110. So you'd have to look here at cluster 110. Here we are. So it's this 110 here. There are 14,000 points in this cluster. So we can get rid of those points. To confirm that, let's get rid of these labels. And now, so you can see that this particular clustering program did not split this up. And in fact, I looked at that particular results, and it's not so obvious. There isn't some difference between the way the points look in the original space and the way they look in 3 dimensions. When you can map into 3 dimensions and find structure which is typically there in the higher dimensions, but maybe not always, and vice versa. So this is not totally reliable. If it was, then you don't always, if you map the 3 dimensions, you obviously are throwing information away. Anyway, you can certainly see here that it looks as though there are at least 2 or maybe more clusters of points within this cluster. So that's the type of thing you can tell from this type of plot. Here's some nice clusters which are obviously very clean, and those are actually pretty globular clusters. We can now go back to our original reset. So that's what it used to be. So we reset ourselves. We've got our axes back. We can get rid of those again. And now we can change the size and look at it. Here's this white cluster 110 that we were looking at before. Let's double check that. It's disappeared on us. Okay, so there we are on that particular 446. So that was a large data set. It was reasonably responsive, although as you saw, I had some trouble myself with the program having waiting, and I'm not quite certain what's going on. So that's probably that's just life. It's an area where we need to improve the program. So we can get rid of that. And then the final example we had here was 100K from a metagenomics sample. This time my click was correct. And here we go up to a big plot. And we can get rid of the axis again, because this one doesn't seem to benefit from an axis. We can make it clearly a little bigger. This is a very globular one. But this is not fully clustered. This is so-called divided into what we call mega regions, which are groups that we can then, which are a bit more manageable in size. Technically, what we do, we take I think there's over 600K points in the original sample. We take a random set of 100K, cluster them very accurately. Use multidimensional scaling on them and clustering to break them up into clearly separated subregions, which we then take the full data sample, interpolate it to the subregions, and then analyze that full data sample. So you can see here there's this purple thing up here, which is one of these mega regions. Maybe no, it's not 10. 10 is that one. It's not that one. It is maybe this one. Yes. So this is mega region 2. And I said the way I find what's going on is to deselect the cluster. The best way of finding a cluster is to deselect it. But anyway, you can see there's a lot of structure here, a lot of clustering. And again, there's over 100 real clusters in this data sample. There is a link in the resource page which will tell you where to find further work on this thing. All right, so that's the end of the examples, I believe. Let's go back to the PowerPoint and finish up. I've given you a lot of examples. Hopefully you learned a little bit about it. You just have to play around with Plotviz, and you can get Plotviz by loading it. And also there are lots of examples here, many of which I went through, and you can also download it for both Macintosh and Windows. There is no Linux version at the moment. And we gradually, every now and then, improve it. And I wish you luck. It was used. I think it is very important to visualize what you do wherever you can. Sometimes you can't. You just get numbers. But when you can get real pictures, pictures are worth 1,000 words or something. So please use those pictures. And here's some comment on the technology. The key graphics technology comes from something called VTK, a very well-known open source visualization library, which is used in many more advanced visualization applications. They're much more advanced than Plotviz. The only feature Plotviz has is it's aimed at doing one thing and one thing only. Lots of points, where those points have features which we found useful when looking at multidimensional scaling and other dimension reduction routines. Qt and Boost are the other two major libraries we use. And that's the end of this presentation on Plotviz. You're welcome to download it and have fun and use it both in this class and also anything else you need to do. Thank you very much.